Hello, year 12s. I hope you're good and you're healthy and you're safe. Okay, before I start, I would like to thank you guys for doing the work week in, week out. Even if it's a late submission, it does not matter at all. But I could see that most of you, if not all, are really working hard. You are investing a lot into your education, which is very, very good. And we all know what is going on in this current situations. And this actually reminds me of a quote by Nelson Mandela, which is education is the most powerful weapon which you can use to change the world. Okay, and I'll actually add to that education and qualification also becomes the most powerful weapons that you could use to change your world, to bridge the gap of inequality that is amongst ourselves, which is purposefully done, and we can rise to that. I know I always say this in our lessons, but we can change the world. We just need to be focused, work hard, and we will move mountains. Okay, so let's move on to today's work, and which is still chapter 11. We're going to be focusing on 11b, using differentiation. Okay, we know that velocity is the rate of change of displacement. We know that from chapter 9. And with the work that you've been doing with Mr. Dyack in Pure, you also know that you could use differentiation to find the gradient function. So v equals ds by dt, the rate of change of velocity. The rate of change of displacement is velocity. Okay, that's where ds by dt is v, and the rate of change of velocity is acceleration, or the second derivative of displacement will give you acceleration. Okay, so we know that. And on the right here, as you can see, if you have displacement, you differentiate displacement going downwards, you get velocity. You differentiate velocity, you get acceleration. Okay, we will talk about integration later on, but upwards, if you integrate, you get back. You see, if you integrate acceleration, you get velocity. If you integrate velocity, you get back to displacement. Okay, so let's just go uh, into example in your book. Example 4 on page 185. Okay, and I read. It says a particle P is moving on the x-axis. At the time t seconds, the displacement x meters from the origin is given by x equals t to the power of 4 minus 32t plus 14. Okay, you're asked to find a, the velocity of p when t equals 3, b, the value of t when p is instantaneously at rest, and lastly c, you're asked to find the acceleration of p when t equals 1.5 seconds. Okay, very, very simple. Well, like I said, we are given displacement function here. And if we have displacement function, if we actually take the derivative of that displacement function, you get our velocity. So what we just need to do is apply the techniques of differentiation that you've been working with Mr. Dyack and differentiate t to the power 4 minus 32t plus 14. Differentiate that, you get your velocity function. Here we go. Okay, so we get 40 cubed minus 32. We have our velocity function here. The rest is just easy. We just need to substitute t equals 3 to find the velocity of p when t equals 3. Make sure that you apply bit maths. Okay, 3 cubed first, times it by 4, take away 32, you have your 76 meters per second. Part B. Find the value of t when p is instantaneously at rest. Instantaneously at rest, what can you say about the velocity? Well, if you said 0, that's fine. That's great. You're right. V equals 0 there. So that means your velocity function from this one here that you obtain from part A, equate that to 0. 40 cubed minus 32 equals 0. Solve it. Simple equation there. 40 cubed equals 32. T cubed equals 8. T equals 2 when you cube root of your 8. Very, very simple. Part C. What is the acceleration of p when t equals 1.5? Well, if we look at the diagram here, we said if we differentiate displacement, we get velocity. We differentiate velocity, we get acceleration. So let's just go back to part B. Let's differentiate this function here, the velocity function. We will obtain the acceleration function. Right? That's what we mean by the second derivative of the displacement function. We've done that twice now. And if we go ahead, we have our 12t squared. Okay, so what do we have? When t equals 1.5, substitute that in, bit mass, 1.5 squared times by 12, we have our 27. Very, very, very simple. Okay.